Hi everyone, welcome to the webinar this morning. We're just going to give it another minute just while people are logging in. Just to give you an opportunity in case you're having any sound issues, just certainly now is the time to correct them. Sometimes you've just got to kind of go back and pick a different audio option. So certainly if you can hear me now, just let us know through the chat window.
All right. Good morning, everyone. My name is Hannah Canning, and I'm a safety advisor here with the Construction Safety Association. So I just want to thank you for taking some time in joining us this morning in this partnership that we have with Workplace NL and Digital Government and Service NL's Occupational Health and Safety Division in promotion of Fall Prevention Awareness Week. So today's webinar will be a discussion on fall restraint. And I'd like to take the opportunity just to thank and to introduce as well Jane Eustace, an industrial hygienist with Workplace NL, who will be walking us through this morning's presentation. So a warm virtual welcome in welcoming Jane here this morning. So it's all up to you now, Jane.
Hi everyone. Yeah, as I've been introduced, I am Jane. Today I'm going to be talking a little bit about fall restraint, but I'm also going to kind of set up or lay the framework for the next couple of presentations that we have included in the fall protection series, which are fall arrest and fall protection planning. So this is a good one to kind of take into, again, if you're planning on participating in the next couple, because we'll talk about some introductory material here. So before we get started, I do want to just introduce you to Fall Prevention Awareness Week, which is the week that we're kind of participating in this week. Again, there's a variety of webinars that are going to be going on this week, and we'll talk a little bit more about other events and things that are going to be available to you at the end of this PowerPoint. But the plan for this series basically is to talk about fall restraint being, we'll say, perhaps the safer or more effective means to kind of deal with working at height, and then moving into fall arrest tomorrow. And then the following day, we'll be talking a little bit more about planning specifically as it relates to working at height as a whole, and taking into consideration, all these different options that are available within restraint and arrest. So a couple of housekeeping items just before we get going. I do want to mention that the purpose of these little training courses is not to take away from any approved training course. For example, the 2-day fall protection course. These little training courses are really designed to just improve our overall knowledge around fall protection. And I'm going to try to keep this presentation somewhat light, and as much as I can, I'm going to try to make it applicable to all of you by giving some examples of my own experiences as a health and safety person dealing with fall protection in workplaces across the province. In addition, I would like to encourage you guys to ask questions. That's certainly very much encouraged. Feel free to put any questions that you have into the software kind of as we're going along. What I'll do is I will look at all the questions at the end and certainly try to answer as many as I can. If you do have any questions for me that are maybe you feel like they're not appropriate for the chat, I can also put my contact information in there, so you can reach out to me on your own, or certainly you can reach out to the NLCSA, and I'm sure they'd be happy to pass your questions along to me as well. I will try to take a little break somewhere in the middle of this presentation. This presentation will be about an hour and a half. So the purpose of that break will just be to give us all a chance to get up away from our desks, move around a little bit. I will walk you guys through a little stretch. If you want to participate in that stretch, it's certainly up to you. I just want to remind any of you that you might be experiencing any kind of medical or health issues, that's certainly you don't need to participate in the stretch. Just getting up and moving around is really the goal of that little break. So today's topic, we are going to look a little bit at statistics. I'm not going to spend too much time on this, but we're going to look at statistics that relate to the construction industry, as it relates to falls, and we're going to go over just some details and some landmark things that have been going on. So without giving away too much, we'll move on. Next thing we'll do is talk a little bit about what fall protection is as a whole. And in particular, we're going to look at the hierarchy that is ideal to use when determining what types of fall protection equipment that you might want to use at your workplace. Next, we're going to get into some of the, I'm going to call them passive fall restraint methods, things like guardrails, because they are very commonly used on construction sites for a lot of purposes. So we're going to spend a little bit of time going over them. Then we're going to move into the guts of our topic, which is fall restraint. And I just want to highlight that the types of things we're going to be talking about will be single point anchor systems, horizontal lifelines, and we'll also talk about the use of fall restraint in aerial work platforms. And then finally, as possibly one of the more complex systems, we will just touch on warning lines or warning systems, which typically are used on roofs, flat roofs, that sort of scenario. And again, after that, we'll open it up to any questions that you may have. So again, to begin, we need to kind of look at the statistics in order to see where we are, where we've been, and kind of areas that we still need to improve. So certainly, just to disclaim here at the beginning, I do want to highlight that the statistics that I'm showing you today are for the construction industry. All the different industries we have in this province are kind of unique. So we wanted to just show you the construction industry rate. I also want to just make a note that this rate is based on a time period of 1997 to present. So we don't have a lot of data that goes beyond 1997 or back beyond 1997. I also want to disclaim that this is claims data. So this is data where someone has made a claim, whether it was for medical aid, for lost time, or for a fatality. And there are lots of reasons why somebody may not make a claim. So there's certainly some gaps, I guess, really is what I want to address here. It's likely that there are some other types of injuries, illnesses occurring from falling from heights, again, that we don't necessarily get to capture if people don't make those types of claims. Now, with regards to this rate that I'm showing you here, it's obvious, I think, to the curve of this graph, that our overall falls from height injury rate in construction is dropping. And it has dropped quite a lot, especially since around 2000, 2001. We also saw some drops in the 2012, 2013 kind of range when we introduced the new training standard. And that became a mandatory requirement here in the province that people have the 2-day fall protection course. But regardless of this drop and this nice kind of downward curve, which is what we want to see, I do want to mention that construction has about 3 times the amount of falls when compared to the province, the rest of the province as a whole. So despite the fact that, again, we've done a lot and we've managed to get our rate down, it's still 3 times as high as a lot of the other industries in our province. So there is really still a lot of work left to be done. Now, when we look at the data on a year-to-year basis, and we look at sort of the number of claims that we're having, we're looking at, again, those 3 categories of fatality, lost time, and medical aid. We do find that the vast majority of the claims that we get related to falls are lost time, but occasionally there is a fatality. And of course, that's a severe outcome that we don't want to see. So regardless, again, of that rate reducing, we are still seeing fatalities with actually 2 happening last year. So again, there's still a lot of work left to be done to ensure that workers are not having serious injuries and fatalities when out on the job. When we look at the types of injuries people typically receive if they fall at work, and again, this is in relation to those injuries that we get claims for, a lot of them do involve fractures, Now, we can't be specific to what parts of the body, but you can imagine that some of those are much more severe than others. We also see a lot of different types of soft tissue injuries. So there's your sprains, your strains, your tears, some non-specific things, so things that we can't really quantify anywhere else, and just general bruises and cuts. But again, there's a big difference in potential severity depending on the nature of the situation that we're looking at here. But again, fractures accounting for 31.5% is again just alluding to the fact that this is certainly a very serious type of injury to receive. Now, maybe more interestingly, we also have the ability to look at the type of accident, which I think is quite interesting and usually helps safety professionals and other people, responsible for safety out on the work site, supervisors and whatnot, to kind of help strategize and really kind of focus in on areas of concern. So when we look at the construction industry, what we find is that the vast majority of falls are from ladders. Again, I want to highlight that that is not necessarily the case in other industries, but in construction, that is a very common type of injury. We've also got, coming in behind that, falls from scaffold, stages, and other types of work platforms. Next to that are falls to the floor. So I do want to mention here that we do call this falls from height, but really what we mean here is falls from anything above surface level. We don't have the ability to quantify the specific height that a person fell from in our claims data. So these are just all falls from any height at all, regardless of what that height is. So we're not following, say, for example, the 10-foot rule that we have in place here in the province for defining working at height. Another one which I think is really important that a lot of people overlook is falls from non-moving vehicles. So these are people getting on and off of vehicles, whether they're getting on and off the back of the vehicle or just getting in and out of the cab. This is actually a really common type of accident, might even be closer to #1 in other industries, but certainly it's not to be overlooked in falls because we do use a lot of equipment in our work to do different types of or different parts of the construction process. Next, behind that, we've got falls from stairs and steps. And I do want to just point out that during construction, sometimes stairs and steps are temporary. Sometimes they may not necessarily have guardrails. So there's a lot of kind of things that come into play with stairs, again, depending on this particular scenario that we're looking at. We've got falls from roofs down below that, falls to a lower level, and then some additional kind of stuff at the end, which again is much less common. When we look at how much this costs, it's pretty expensive. These are, for the most part, again, serious injuries. So it's around $4 million and change on a yearly basis for us to cover the cost of compensation for those workers that are injured, again, just in the construction industry. So moving away from the stats, again, I just want to highlight that when people fall in the construction industry, sometimes it is a very serious event. It isn't always from things, or it's not as, we may perceive that the more common sources of injury are things like falling from a roof, but we find within our data that falls from things like ladders and scaffolds are actually much more common. So the latest statistics I'm going to share next are from OSH Division. So again, that's the Department of Digital Government and Service-NL. They just kind of changed their name at the end of the year, so I'm just going to call them OSH Division from here on out for simplicity's sake. So we asked them to just provide us with some of the types of work orders that or directives that they've provided to employers, and again, recently in the last 5 years or so. And what we found was that the #1 type of order that was given was inadequate fall protection. So the system itself, whether it's the harness, the lanyard, the anchor point, there was something within that system that was inadequate to protect workers. Next to that was lack of training. So yes, we did introduce that mandatory training standard in the province, again, around 2012. don't quote me on that date, it's somewhere around there, that had made some big improvements again to that industry rate, but we still have a lot of people out there who are not trained in fall protection or in the use of, say, a particular type of lift, like an aerial work platform or a scissor lift, for example. So that is still an issue, and we still run into issues as well of people whose training expires and they continue to carry on working. It is really important to make sure your fall protection training is kept up to date. Once it expires, certainly you've got to redo it. The next one we have there is inadequately secured fall arrest systems. So these are systems that are specifically tied back to the anchor point, whether or not that's a piece of equipment that you're using, or it's the actual structure that you're tying off to. So maybe it's a steel beam or a piece of wood or what have you. Next one below that is issues with the lifeline. I've got some examples that I'm going to talk about that I've experienced with lifelines and lanyards, and certainly those two pieces of equipment are somewhat interchangeable, lifeline and lanyard, but they do need to be set up correctly to ensure that workers don't have the potential to hit the surface below, and that's really critical. And you'll hear more about that when we get into fall arrest tomorrow and fall protection planning on the following day. And then again, keeping her down, we've got some inadequate pre-use inspections. So again, that's tying back to aerial work platforms, things again like scissor lifts and boom trucks and articulating booms and things like that. They have given out some orders related to inadequate fall protection plans. I think it's kind of neat that they use the term inadequate. I'm sure in some cases there was a lack of any plan whatsoever, but there is a requirement when you're working at height to have a fall protection plan in place. And again, I would encourage you to check out the presentation we're going to do, not tomorrow, but the next day, for more information on planning. Okay, so moving on from all the data, hopefully that's given you sort of a little bit of an insight into, again, areas of particular concern as it relates to claims and as it relates to OHS directives. Now we're going to kind of switch gears and we're going to talk about fall protection. We're going to start from the basics and kind of work our way into fall restraint. So here in the province, we define working at height as working at 3 meters, which is 10 feet or greater, or working above something that if you fell onto it or into it, it could hurt you, or if you're working above an open tank, pit, or vat that contains a hazardous material. So I want to just point out that these are ORs, so it's important to think about all 3 of these. I do find that sometimes when I'm out in the field, people just use the 10-foot rule and they kind of forget about the other 2 items, which are also very important. You could easily be working a foot above something that if you were to fall into it, it could hurt you. Think about moving equipment. I have actually had, secondhand, I've heard of some situations where people have fallen into containers. In particular, one that comes to mind was a story I heard years ago about someone who fell into a sewage tank. He was walking across like a platform on an open topped tank, and he fell in, and unfortunately the employer didn't really have a procedure in place for rescuing someone from that tank, and I think one of his coworkers got him to grab onto to a mop or something and kind of hauled him out. But again, I just want to highlight that working at height, yes, in the province, we do define that as 3 meters or 10 feet. But again, there's more to it than that. It could be less if, again, there is something that you could fall onto or into that could harm a worker. Now, federally, the rules are a little bit different. And I want to highlight this because sometimes as contractors, we're going into other people's businesses, and we need to realize that provincially regulated employers have different rules than federally regulated employers. So with regards to the federal companies, so this would be, your Canada Post, the banks, there's a variety of places that would fall in there, the rail system up in Labrador. Their rule of thumb is from a structure or a vehicle at a height of 3 meters or more, from a ladder at a height of 3 meters or more, if, because of the nature of the work, the person is unable to at least have one hand hold on to the ladder. So the idea there is basically if you can't maintain 3-point contact with 2 feet and one hand holding on to a ladder and you're above 3 meters, then you're in a working at height situation. And that's a tricky one to enforce. I got to say, I've had some issues with trying to, get people to tie off on ladders, especially when you're moving ladders around a lot to do work. Say maybe you're doing electrical work and you're shifting the ladder every few feet. That can be very, very tangly. So certainly it's a better idea to maintain the 3-point contact if possible. And then finally, they also consider working at height as a height less than 3 meters. Again, if there is a surface onto which the worker may fall that poses a greater risk of injury than a solid surface, so something other than hitting a flat floor. So it could be maybe there's stacked materials that could pose an impalement hazard. The person might fall into water or again, a liquid where there may be risk of drowning. There can be a lot of situations, again, under 3 meters where there can still be a risk of injury or illness to the worker. So returning back to our provincial regs, because that's really what we're going to kind of focus on here. We do have OHS regulations in this province, and I just want to mention to you that Part 10, which is X, is the fall protection section. So this is the main section, the section that you certainly want to be familiar with if you're using fall protection or you're working at height. There's a lot of great information in there, but there are a couple of other sections that you might also want to have a look at. There are some very specific types of work that we didn't really roll up into that fall protection section. So just to give you some examples, we've got openings, pits, and tanks, roof work. There's information about scaffold stages and work platforms, as well as, powered mobile equipment and things like that. So there's a lot of stuff in there that's also useful, and you'll even find some information there around emergency plans and things of that nature. In addition to the provincial regs, we also have a couple of standards organizations that we have referenced in our regulations, which means they're enforceable. And this is common practice in the different provincial jurisdictions. There are all kinds of standards organizations within Canada, like the CSA, the Canadian Standards Board, as well as in other places. Like, for example, ANSI is in America. It's the American National Standards Institute. So sometimes we will see a standard and we'll determine that it's good and it meets our I guess, legislative requirements here in the province. So we'll adopt it by actually writing it into our legislation. So there's a variety of CSA standards that we have done this with as it relates to fall protection, but not all. And it's important to note that because although there are some standards out there that maybe aren't enforceable, they do have a lot of really useful practical information in them. And of course, the CSA is always creating new standards. So sometimes a really, again, useful standard will come out that it just so happens it didn't exist when we last changed our regulations. So just to give you a couple examples of some of the ones that are not included, there is a CSA standard on anchor points that is, again, not referenced in our regs. There's also another one on retracting, self-retracting lifelines and lanyards, which is another example of another good one. And we do use ANSI for a few things, like, for example, ladders. That is the standard we use. So just to give you some examples, again, of the ones that we reference. So a lot of the different parts of the fall arrest equipment, or same equipment you would use for fall restraint. That one at the second from the bottom there, designing fall protection systems, is fantastic. This one is a little bit more about planning and talks a bit more to the supervisor or the person that's actually setting the system up. And again, in mention to those ones that are not referenced, we've got, again, anchor connectors, self-retracting devices, and additional ones again as they come up. But again, these are great standards that certainly are useful to have. So fall protection as a term means anything that you might do in the workplace to protect a worker from falling. I want to highlight that for anyone who's been in the industry for many years. There was a lot of terms that used to be used to refer to fall protection training, things like harness training or fall arrest training. Really, fall protection is the umbrella term that kind of covers all the possible things that we could do. And we could, in theory, kind of break that into two categories. It either prevents someone from falling to begin with, and the best example of that we're going to talk about today is fall restraint, or it protects a fallen worker against injury after they've fallen. And these would be examples like fall arrest or safety nets. So again, just to reiterate that, fall restraint prevents someone from falling to begin with. Fall arrest has the potential to protect them from injury when they fall. But I do want to highlight there that if you fall in your fall arrest and your equipment works as it's meant to, and you're suspended, it is still possible that you may be injured. So we can't really say that it 100% protects you from fall injuries. It simply reduces potential injury if you were to fall, which is certainly not as effective as something like fall restraint. Now, before we go much further, I do want to just mention as well that I will be using the term fall restraint just to keep things consistent here, but a lot of people also use the term travel restraint, kind of similar to fall protection being called harness training and all these different things. Travel restraint and fall restraint can kind of be used interchangeably. I'm just using the term fall restraint here because really what we're trying to protect people from is a fall, whereas travel restraint can also be used in a lot of other different scenarios. Like, for example, you might be in a manufacturing setup and you may have travel restraint in place so that people don't cross into a work area where there's, I don't know, maybe automation going on. So again, bear with me on that. If you're familiar with the term travel restraint, that's fine. Really, it's just a terminology piece. So when we think about the hierarchy of controls, which is a very common term that we talk about a lot in health and safety training, the whole idea of, using controls in a particular order to ensure that we take the most effective controls are considered first, and we wait and kind of use the least effective ones at the end, only when we've kind of explored all other options and determined that they're just not good enough. So when we think about fall protection, arguably you could consider this to be the hierarchy of controls. So certainly number one is eliminate the possibility of a fall altogether. So I will give some examples in a minute, but just to kind of get the ball rolling here, one example would be is if you have an open hole, cover it with something that would eliminate that risk. Again, the next option would be something like fall restraint. So we've got workers working around said open hole, but they can't get close enough to it to fall. So they don't have that, again, they don't have the potential to fall there. The last option really that should be considered is arrest or a safety net, which we're not going to talk too much about today because they're not commonly used here in the province. That, again, is the last option because as a type of PPE, there's a lot of compliance issues. People do need to wear things properly for the system to work properly. Again, the system needs to be set up properly as well. But also you have that potential for, again, the person to be injured if their system works and they are left suspended. And it's better to never fall and never be suspended to begin with, if at all possible. So that's kind of the hierarchy that we're going to be talking about. Again, I do want to talk a little bit about guardrails before we get into fall restraint. I think this is an important piece, and this was kind of the best spot to kind of feed this into our series. As a more of a passive system, certainly, in that it doesn't require workers to do anything. So, you find a hazard, you set the guardrails up properly, which we're going to talk about now in a minute. And in theory, you should be able to just step away from that hazard, It's been controlled. The workers don't need to do anything. It's dealt with. And again, this is a bit of a preferred method if you can do it. So guardrails. I know this seems like a basic topic that maybe some of you are thinking, oh, well, you know, why do we need to talk about guardrails? I can't even count the number of times that I went on to different types of sites, construction and otherwise, when the type of guardrail that was being used was inappropriate. So I will give some examples certainly as we go. But a guardrail is a piece of equipment that you install or build that helps to protect an edge that otherwise, you know, if someone was to step over it, they could fall. So it's a barrier. It's a physical barrier. So there's some requirements that are necessary for it to work properly. So as I mentioned, it's a passive fall protection system. It doesn't require any extra work from the user, which is great. No training needed. So for example, if you have, say, a roof that people are regularly getting up onto, let's just say we've got, say, an HVAC system on the roof that needs annual maintenance, we can set up a perimeter guardrail around that roof, and we can basically ensure that people are protected from that hazard the second they step onto it. Again, seems great, but there's lots of downsides. One good example of a negative, or we'll say a disadvantage of guardrails is they can be a little bit expensive. Certainly permanent guardrails on a rooftop would be more expensive than, say, a temporary system, or doing something like simply putting people in fall arrest. But again, referring back to that hierarchy we talked about, we should be trying to use these methods first, again, and really only move it into fall arrest if the other options aren't practical. So guardrails can be used in all kinds of scenarios. They're on most of our elevated work platforms, or our aerial work platforms, or AWPs. They can be on top of pieces of equipment. They can again be surrounding a flat roof. Usually they are used in situations where the surface that you're getting onto is flat. It's rare to see them on angled roofs. One scenario that I really like to see them is in that middle picture on the bottom row, where you see the guardrail around a roof hatch. Again, there's a lot of openings, we'll say, on roofs and in our different industrial sites around the province, where we've got openings that are open and shut depending on what type of work is going on. So it's nice to have those rails in place to protect workers, especially when they're using that opening a lot. Even the guardrail that's on a scaffold, again, needs to meet certain requirements, which we're going to talk about now shortly. So again, there's lots of applications here, generally permanent, but often they can be, again, a temporary situation. So the spec for guardrails, they need to be used whenever there is an open-sided floor, so someplace that people normally walk, whether it's, you know, a ramp or a flat surface. Anywhere where there's a potential for a 4-foot drop to another level, there needs to be a guardrail. So that would include things like walkways over open tanks, and I think I showed a picture of that a minute ago, and certainly chatted about that story there earlier. And any other type of walkways over open tanks containing a harmful substance. So again, 4 feet is out the window if that particular tank contains something that's extremely harmful. Let's just say acid or something ridiculous, ridiculously dangerous. So again, guardrails a little bit different than the working at height legislation. It's the 4-foot instead of that 10-foot piece. Where they are used, they need to go all the way around the hazard. This is a really important one. I find a lot of the times, you know, on work sites, little gaps are left for equipment to come in and out, or for people to come in and out, but it is really important that that guardrail system goes all the way around the hazard. It should also be secured so it can't move. Keeping in mind that the guardrail is meant to be a physical barrier. So someone's meant to be able to go up to that guardrail and lean on it, and it should prevent them from falling. Again, I've seen a lot of interesting things over the years. I do recall a job years and years ago where some work was being done around a swimming pool. The swimming pool was empty, and around the deep end of the pool, they had placed guardrails to make sure that workers wouldn't fall in, because again, the pool is empty. However, these guardrails were not secured to the floor because of the tiles around the swimming pool. They didn't want to damage it. As a result, during a toolbox meeting, someone leaned on these guardrails and fell into the pool. And the argument was, well, you know, those rails are there as a visual indicator. They're not there for you to lean on. Again, guardrails need to be able to be secured. They need to be able to prevent movement. If you're putting up a guardrail system that is not secured, it needs to be at least 6 feet or so back from that edge, so that if someone does lean on it, they're not going to fall into the open area. They do need to be able to withstand a certain amount of weight, pounds of force, and I won't get into that in any detail. And they should also include little detour components where you might have somebody exiting a guardrailed area to use stairs or to cross, say, over to another area where perhaps there's traffic or some other type of hazard. So as I mentioned, they can be temporary or permanent. So the temporary ones are usually ones people purchase, or they can also be job made. So people might build them out of wood or scaffold components or who knows. But they do need to be built to a certain spec. So if you're building your own guardrail, it's important that the top rail is between 0.9 and 1.1 meters from the ground. There's a certain minimum height. So let's just say I'm up on a roof and it's a flat roof and it's got that little lip that goes around the outer perimeter of the roof. If that lip doesn't go between 0.9 and 1.1 meters, I need to add a guardrail at least up to that height to match the missing kind of component that's not there. They also need to include a toe board. So that's that little strip of wood, or it could be metal if we're talking about a scaffold, on the bottom. That toe board needs to be there if there's a potential for stuff that's up at height to be kicked off the roof or whatever it is we're working on, where there might be people down below. So the idea there is to kind of protect those workers down below from dropped objects and things of that nature. And again, it also needs to include a mid rail. So that's a rail that's just somewhere in the middle between the top and the toe board. And of course, there's also requirements for not bracing, what's the word I'm looking for? Poles, basically, that support the guardrail system at regular intervals, so that again it doesn't have the potential to collapse. So those are those kind of vertical components that you can see in the image. So when we're building guardrails, we just need to keep in mind that there is a specific design we're meant to follow, and we need to follow it. If the rail is too small, if it's too low, there's a potential that if someone comes up to it, that it could hit them in a part of their body where their center of gravity could cause them to fall over the rail. So there is some kind of science and engineering behind this spec. And I think I've maybe talked that to death, so we'll move on. With regards to guardrail use, they should be there. I should say workers who are installing guardrails. So say again, we're in an area where we've been on an open edge that we're putting a guardrail on. It's important to keep in mind that the workers doing that job are at risk. So they really should be using some kind of restraint or arrest system while they're doing the installation piece. And workers should never climb on railing or reach between the rails, like this picture I've got on the right. Again, that guardrail is there to protect you from falling. It's a means of fall protection. It's part of the safety features of that piece of equipment. Or again, maybe it's a scaffold or who knows. We're never supposed to climb the railing or even really be reaching out beyond the rails, because there's that added potential that we could fall. So this is a big no-no. Okay, so I think I'm gonna maybe take a little break there. What are we looking at here? No, I think we still gotta, yeah, maybe we'll just do like a quick 2-minute break here. We're not quite in the middle yet, but I think maybe I've covered enough information to justify a little break. So this is going to be, just a minute or two. Again, the purpose of this break is really to get you up out of your chair and get you moving around, not to have you go off and check your email or what have you. I am actually going to take you guys through a little stretch. Again, if you would like to participate, feel free. I'm just going to talk you through this one rather than switching on my camera. So we're going to just kind of stretch out the upper back and shoulders. So again, standing up out of the seat if possible. I'm going to get you to just lace your fingers together in front of you, and then actually just stretch your arms out right in front of you, so sort of horizontal, palms kind of facing away from you. And we're really just trying to stretch out the upper arms a little bit. This stretch shouldn't be painful, so you want to just get that feeling of stretch going, and again, not go too far with it. And then the next thing we're going to do is we're actually going to take this overhead. So we're going to take our hands back in towards our chest and then reach them up to the sky, still, again, fingers interlaced. And we're going to just see how tall we can get. And I do encourage you all to try to just sit up a little bit taller, stretch a little bit taller. And again, we're trying to really stretch out those upper shoulders and the back. Perfect. I do want to encourage you just to get up and stretch, move around again as much as you can throughout this presentation. But I think we will go ahead and get this kicked back off again. Okay, so our next topic is fall restraint. So this is really the guts of what I wanted to get into today. Again, it is a good practice to try to use fall restraint instead of fall arrest, if at all possible. Again, because it puts your workers in a situation where in theory they shouldn't be falling, again, if the system is set up properly. So the need for rescue and whatnot should not exist. So a fall restraint system, basically what you're doing is you're restraining the worker from reaching and falling over an unprotected edge. They're kind of two types, and I do want to talk a little bit about each to give you some detail on kind of how these systems can be used. The first type, again, is, and I mentioned this earlier in the presentation, is the fixed single point system. This is probably the most common system that's used. A little bit more complex are the horizontal lifelines. And I do want to mention that both of these can also be used for fall arrest. But again, we're just going to be talking about this as it relates to restraint. But this will be a good intro again for the fall arrest topic that is tomorrow. And then once I get into these two different types of systems, I'm just going to kind of follow up on the uses of fall restraint again in AWPs, which is often an area that people have questions about. So a fixed single point anchor system means you have one anchor that's fixed to the ground or fixed to some sort of structural component. It's usually used for just one person at a time, as most anchor point systems are designed for just one worker. Horizontal lifelines would be a little bit of an exception to that rule. Often they can be designed for multiple workers, but again, we'll talk more about them later. So usually you're working in a very specific defined work area. So you've got your anchor points either placed, in a safe location, certainly, that you can attach to, but also near to the work area. Usually it consists of a harness, so that's a full body harness, a lanyard or a lifeline, depending on what you're using. Again, those terms are a little bit interchangeable. It's basically the rope that connects your harness to whatever you're tied off to, your anchor point. So this again is a good example of a single point system where we've got someone up on a roof. He's got his anchor point located, we'll say, within that 6.5 feet from the edge, so he can tie off safely. And then his system allows him to get to that edge and do his work. Maybe he's installing a guardrail, who knows? But there's not enough give in the lanyard or the lifeline to allow him to fall over that edge. Even though this is restraint, I do want to highlight that planning is really important. Sometimes I've gotten into conversations with people that when they're using fall restraint, they don't have to do all the pre-planning and stuff that they would normally need for fall arrest, because again, the idea is that you shouldn't fall to begin with. The reality here is that the fall restraint system has to be set up just so that the worker doesn't have, again, that extra bit of room that really would just be a tiny bit of extra room that would be required to cause them to fall. So again, there's requirements that need to be considered. And one of the most important ones, arguably, is the length of that lanyard or lifeline, and secondarily, the position of the anchor itself. And within fall restraint, supervision can also be really important, especially if you're using any type of equipment that has the ability to be adjusted. Sometimes, again, you give a crew a particular type of setup. You let them know this is the length that you're supposed to be using and whatnot. But if it's adjustable and they're doing something and they need just a little bit of extra space, sometimes they will, use that space if it's available to them. So supervision plays a crucial role in making sure that workers stick to the plan. And if they have questions about the plan, they can be dealt with. Like, for example, if we are in a scenario where my fall restraint system has been set up, but I don't actually have enough lanyard length to get to my work area and do the job that I need to be doing, really I should be going back to the person who set up that plan, the supervisor ideally, and tell them that the plan is not working so that it can be adjusted. I shouldn't be coming up with ways to carry on doing the work on my own. With single point systems, it is a good idea to have some kind of system around the area to warn other workers that there's a working at height hazard. And I do think that fall protection and working at height, when you're doing it from the planning perspective, it's really two pieces. It's protecting the workers that are actually doing the work, so the ones that are at risk of falling, but it's also protecting everyone else who might be at that work site from potentially entering into the area where that work is going on. So again, there's kind of the workers that are in theory protected, again, assuming your system is set up correctly, and then there's those unprotected workers who might just be in the area. So it is a good idea to have some kind of suitable barrier, and I'm going to say suitable because again, there's a lot of variation there from what I've seen over the years with regards to barriers. They could be something like a hard barrier, like a guardrail, like what we talked about earlier. And if you are using hard barriers, again, you have the benefit of being able to put them close to the hazard, like around an open hole or something like that. But if you're using soft barriers, and what I mean by soft barriers are things like flagging and danger tape, it's really important to keep in mind that these types of warning systems are visual systems, and they're not actually going to stop anyone physically from falling into an opening. They're there just to warn, and for that reason, it's a good idea to set them up at a distance from, say, an edge, so that people have the ability to see it, recognize there's an issue, and again, they're not right on top of that hazard. And just to give you an example of some situations where I've seen that done incorrectly, I have worked on some sites where the danger tape was put, directly at the edge. And unfortunately, in certain types of working environments, there can be issues with lighting. And again, can be problematic if that barrier is set up right at the edge. You could imagine that someone just might not notice it. And again, that can be quite a problem. So you may use a lot of different options for warning systems. Again, from hard barriers to soft barriers. In either case, it's a really good idea to have some signage present to alert people to what the hazard is, and any requirements for PPE, like the signage that's in this on this slide here. So fall protection required. Again, these types of things help protect other workers in the area who might just be popping in to do some quick piece of work. With regards to anchor points, they should follow all the same rules that we would use for fall arrest. So the point in a way, it could be considered to be two things. It's the structure that you're tying off to. So that could be, you know, steel or wood beams or who knows. It certainly shouldn't be anything flimsy that you couldn't support your weight. I did actually recently see a picture of someone who had been tied off to some duct work here in the city area. So people are still tying off to things that they shouldn't be. Certainly a good rule of thumb is if you wouldn't hang a full-size truck off of that item, whatever it is that you're using to attach your system to, is probably not the place where you should be tying off. Keeping in mind too that it's not just your weight that system's going to have to support, but the force of your weight falling and then coming to a sudden stop, which generally speaking is significantly more force than your weight alone. So this helps protect the whole system really in the event that there's misuse. So yes, this is restraint. In theory, we shouldn't fall, so the anchor point shouldn't need to take that fall force again when someone falls and comes to a stop. But because of potential misuse, the anchor needs to be equally as good as if it was used for a rest. Again, to highlight that usually anchor points are only for one person at a time, but that can vary. So you want to make sure that you pick a system that is going to work for the number of workers you need to do that job. Again, you don't want more than one person tying off to an anchor if it's not designed for that. When you do have a lot of workers working together, and if you are using single point anchors, you want to make sure that you space these workers out to make sure that their lifelines or lanyards don't get tangled together. And that can happen when you have a lot of people working on a site, and really does create some trip hazards and things of that nature. Another really important piece, which I alluded to earlier, is the length of that lanyard or lifeline. Again, the whole purpose of this lanyard or lifeline is it's meant to be only just so long as they can reach just the edge, or for that matter, if they don't need to get to the edge, it needs to be just long enough so that they can get to the work area without falling. You don't want to use an adjustable system, because again, it's been my experience that if you use a system that's adjustable, then the guys are going to adjust it. Guys or girls, I do mean, when I say guys, I mean that just in the royal we kind of scenario, to include both girls and guys. But there is, again, no, we want to make sure that this length is fixed and that workers don't have the ability to adjust it. Because again, if they do, they might be tempted to do it, and again, then we're in a situation where they actually need fall arrest instead of fall restraint. So generally speaking, you're trying to stay away from things like retractables if you're using restraint, because again, it's an adjustable situation. When you're using retractable systems, yes, they do reduce potential free fall if it's an arrest scenario, but again, with restraint, they just provide workers with potentially more room than they may need. If this is your only option, I would suggest using or assuming that they're going to use the maximum length of that retractable if it's fully deployed. So assume the entire length of the lanyard will be used. So again, single point anchor points, fixed single point systems are common. It's a practical way to use fall arrest. But again, there are some scenarios where they don't work. And generally speaking, this is where horizontal lifelines come into play. These can be more expensive because generally speaking, they require more physical infrastructure and setup. You may even need a professional engineer to certify these systems, depending on the nature of how it's set up. But these can be used for one worker or for multiple workers. And usually they're employed when a worker has to travel a long distance in one direction. So often there is that track or rail that they're attached to. So in the picture I've got here, I've got an individual who's up on a rail car. So this is a train scenario. Obviously, he's over his limit for working at height, but the particular system he's got in place here allows him to walk the length of that rail car, and let's just say he's opening vents or something like that, without actually getting, again, near to the edge where he may fall. So just to give you a little bit of another example of this, where the worker is tied off above his head, because obviously with this previous picture, we've got somebody who's tied off at their feet. Same sort of idea. You would have a rail or a line that stretches between 2 points, and the worker ties off to that. Now, this particular scenario is more of a fall arrest situation, because obviously this is somebody crossing on a beam. But again, I'm just trying to get across to you the components, which is, again, really the 2 anchor points instead of 1, with a line in between. And again, there are a lot of specifics as far as how these systems should be set up. Generally speaking, you can't just go out and build one of these systems yourself. You either need to buy a system or purchase a system and follow the manufacturer's directions in setting it up, or you need to have a professional engineer design and sign off on the system that you're going to be using if a system cannot be purchased. Generally speaking, if we talk about the lifeline or lanyard component of this horizontal system, it can be a rope, it can be a cable, it can be a rail. Generally speaking, those are the most common ones. But I do want to just point out that this is all specialized material, again, that's been designed to take the arresting force in the event someone did fall. Again, these are designed typically for fall restraint, but they still need to be able to be capable of taking the forces in the event, again, of misuse. So specialized rope, this is a specialized lifeline. This is not just rope that you would find lying around. And just in reference to that beautiful anchor point ductwork situation that I saw just a couple weeks ago in the downtown St. John's area, that was random rope tied together in knots, and it was really a bit of a mess. Yeah, so again, this can look different ways, and again, you might have multiple workers working on this. It all just kind of depends on the specific project that you're working on. As I mentioned earlier, they do need to be designed to a very specific spec. So if they're not a pre-engineered kit, something that you, again, purchase and set up according to the instructions, you got to get the design from a professional engineer. And they do actually need to certify the horizontal system once it's been installed. So there's a lot more to these, a lot more administrative overhead. Usually I see these used in situations where you have a regular piece of work that's being done. And for that reason, I don't see them as being maybe really practical in construction, because with construction sites, as you all know, there's an ever-changing environment as you're building or demolishing, for that matter. Instructions on the lifeline should include all kinds of information. Again, this would be just in the manufacturer's instructions. So they would give you guidelines around, the types of anchors you can attach this system to, the maximum vertical distance across the system, and requirements for things like supports. The line itself can only have so much sag in it, so usually there's a tension requirement. There's these little turn buckles on it that you would need to adjust to make sure, again, that there's not too much sag or whatnot in the line. Again, there should be a certain number of maximum workers noted, any kind of requirements for maintenance. And again, if you are using it for arrest, you'd have to get into clearance and clearance calculations. And again, I would refer you to the next couple of PowerPoints to chat about that. So AWPs, I mentioned I wanted to talk a little bit about aerial work platforms. So just to introduce this topic for those who may not be familiar, aerial work platform is kind of a common term used for any type of equipment, usually mobile equipment, that lifts a worker. It's meant to provide a platform on which the worker can work at height, so thus the name. It's also commonly called an elevating work platform, and I'm just going to use the term aerial or AWP here in this presentation. So there's oodles and oodles of different kinds of AWPs out there. Scissor lifts are one example, and that's second from the right in this picture. We've also got all kinds of articulating booms. Again, there's all kinds of different names for these. Sometimes people refer to them as their brand name, or they'll just kind of come up with colloquial terms like cherry pickers and whatnot. But again, the key point here is you're putting a worker up at height. So when using AWPs, there is a requirement that workers tie off on entry to the AWP. So when you get in the basket or the bucket or whatever it is that you're entering into, that platform that's going to be elevated, you do have to tie off. I often get a lot of questions about the tie off, where they should tie off, whether or not it's safer to tie off to the platform or say some outside structure. So I wanted to just chat a little bit about those types of questions. The purpose of tie off in an AWP is really for fall restraint more than fall arrest. And you can kind of pick up that nuance when you read our regulations and kind of how they're written. I would kind of encourage people to think of tie off in an AWP as kind of a seat belt that prevents the worker from being flung out of the basket if the AWP was being moved and there was a sudden jerk or something that again would cause someone in the basket to be ejected. They're not really there to protect you from activities like climbing up on the guardrails and then falling out of the basket. Or, for example, using the AWP to access another area and getting in and out of it. That's not really the point of it. Again, it's more like a seat belt, really, again, that's meant to protect workers from getting ejected. And there are some videos on YouTube that I would encourage you to go check out of some different groups that have done some tests using dummies and kind of tied them off to AWPs and just showed the amount of force really that can be generated if an AWP rolls over just a little bump and God forbid the platform itself is up when the system was moved. Now I'm not trying to get into a big aside here on AWPs, but generally speaking, you don't move them when they're elevated, except just minor adjustments to try to get yourself into a work area. You're not driving them. But if you were to drive them, again, there's a major potential risk of being ejected. So again, this is kind of where this tie-off comes into play. I also want to just highlight that aerial work platforms, in addition to this tie-off requirement, also have guardrails. So in theory, they have a fall protection component in place already with the guardrails. The tie-off kind of got added because people kept misusing the AWPs. And again, for the most part, it's driving them when the basket is in the fully elevated position that is the most dangerous. Yeah, so I think that's about all I have to say about that. And I'm sure some people probably have some questions about that. I am getting sort of close to the end, so I just want to remind participants, if you have questions, again, please feel free to put them into the window. When I get to the end, I'll review them all at, kind of in one shot. So if they're all there, kind of ready for me to go over, then that's really great for me. Okay, so the last thing I wanted to chat about was warning line systems. So this is kind of like really ideally last option. Again, these systems are not particularly useful because they don't provide that hard barrier. There's some administrative elements here and supervision potentially required. But they are an option, so I wanted to chat about them. So this is the idea of basically putting a barrier on something like a flat surface. So I'm just going to use the example of a roof to warn workers up on that roof that are working in the area in the middle where it's safe, where the potential to fall is very low because there's no unprotected edge. It's to warn them that they're potentially entering into a part of the work area where they need fall protection. Again, these are flags or caution tape. So they can't be set up at the edge. They need to be in a ways so that people have some wiggle room to ensure that they don't fall. So just to give some examples, I want to tie this into the roofing legislation, which again is in a separate section than fall protection, but it's a really important piece of legislation to have your head around if you're doing roof work, which I would imagine that most construction companies are, whether they're building roofs, tearing them down, or just getting up there to fix a thing. So the rules for roofs depend on the pitch of the roof. So the pitch is the rise over run, and I'm just going to refer you to that little triangle I got up at the top of the image. All the roofs in our legislation, we kind of use a rise of between 0 and 12 and a run of 12. We always use that 12 on the bottom. That's our kind of base. So a flat roof would be effectively 0 over 12, so flat, to 3 over 12, so just a very, very small amount of a pitch. And all of the legislation is based on that pitch. So if you're working on a roof, step one is to find out what the pitch of the roof is. If it's flat, you have the most options. So you have the ability, again, to set up a fall protection zone and a control zone, kind of like what we talked about before. In the control zone, in theory, workers are not near the edge, so they shouldn't need any type of fall protection. But they do need to at least know when they're getting close to that fall protection zone, that line on the ground that says you got to put your fall protection on if you go over this line. So again, we use a barrier or flagging or something along those lines to, again, tell people this is the control zone, you're allowed in there with nothing on, but if you step over this line, you need your fall protection on. Generally speaking, that line goes within 6.5 feet of the eave. That is, again, in the roofing legislation. And I like to refer people to that really whenever they're setting up a soft barrier. And maybe that's a little bit beyond what our legislation truly requires, but I think it's a good best practice when you're using flagging or caution tape or danger tape or anything like that to try to keep it 6.5 feet back. Again, I think about that swimming pool scenario, and if that unsecured guardrail had have been 6.5 feet back from the edge of that pool, the worker would have just tipped the rail over and likely wouldn't have been harmed, or at least the harm would have been significantly less. So 6.5 feet rule, again, from the edge is what's used, and at that point you have to use some type of fall protection. So again, it could be a guardrail or a restraint or rest, and again, you need that barrier defining between the two. There is a potential situation where you could get away from using a barrier, and actually I'm just going to pop back to my previous slide. That barrier, ideally, again, should be raised up off the ground with flagging. So we've got poles, flags, you know, some lines, some signage in there to say you're about to cross the line. A significantly less effective way to do that, let's just say if it's impractical to use flagging and barriers, would be to have a person assigned to make sure that nobody steps outside that zone. They probably would still need to have identifiers on the ground to make it such that that person knows when people are getting too close to the edge. But this is a really tangly scenario to use. That person really needs to have authority to make sure that people do not step over that line. And they shouldn't be doing anything else at all. It's kind of like fire watch or confined space attendants. They're meant to be doing just that job and nothing else, because they effectively are the barrier and they can't have their attention drawn away from something else. And now there are some situations where this may literally be the only option that you've got, and the things that come to mind in particular are roof work. For example, if I was, say, applying a new torch on to a roof. So torch on is kind of a type of shingling material. It comes in big rolls or sheets that actually get applied to the roof using mastic, this black goop. and as well heat kind of helps it all seal together. So what you'll see people doing when they're installing a new roof is they'll roll these big sheets out, and then they'll move in a backward motion, which is certainly not ideal for safety, but they'll go backwards with this with this torch. I shouldn't say little, it's not little, and they'll heat the torch on as they go, backing up and heating the torch on, again, right up to the edge of a roof. So you know, this might be a scenario where you might have to use a monitor because you can't put barriers and flags and things in place because you're effectively changing the roof as you go. Again, I would consider this to be a high risk option, which really should only be used when there really is nothing else you can conceivably do in this scenario. Now, moving back to our other types of roofing work, in addition to the flat roofs, there are all kinds of requirements for roofs that are pitched. And I didn't want to get into them in too much detail today, but generally speaking, there's 3 categories of pitched roof. And with the lowest category, 3 on 12 to 6 on 12, you have 3 options for protecting workers from falling. You can put a guardrail all the way around the edge of the roof. You can fully deck scaffolding all around the edge of the roof. You can use toe boards and things like that as well in conjunction with that. And then you also have the option to use fall arrest. With the next steepest roof up, which is 6 on 12 to 9 on 12, you have to use 2 things instead of 3. So we're kind of adding an extra bit of safety. And then with the most dangerous, the highest pitch, which is the 9 on 12s to 12 on 12s, I guess suppose a 12 on 12 couldn't really exist. That would be just a vertical structure. But the most stringent rules have to be used, and it's very specific in our regulations what's required for roofing in that category. I think I did one job once where I had to get up on a roof that was somewhere in the 9 on 12 range, and didn't like it. I gotta say, that's just a little too steep for me, especially with the winds that we have here in our province in various areas. So I wanted to just cover a couple of scenarios to kind of tie all this together with a bit of a bow. It's 11:15 now, so I'm certainly going to try to do 1 or 2 of these before we get into the questions section. So I think I've got a decent picture here. Maybe some of you guys have seen this in the past. This image comes from OSHA, I believe. But I think this is a good picture of a standard setup that you would see in a lot of types of construction environments when people are building multi-story buildings. So think about this as being perhaps, I don't know, could be a parking garage, could be a high-rise that's being built. But generally speaking, when we're building something, we do it a floor at a time. And often for upper levels, we have to bring materials up using a crane or, you know, other techniques to try to get those materials up to higher levels. And it's pretty common to see people removing a section of guardrail to allow for that crane or whatever you're using, again, to bring those materials up. So if we can kind of think about this as the scenario we're in, we've got, again, a parking garage. Let's just say we've removed a section of guardrail, which is just where the worker is standing, again, so someone else can bring materials up to that level. So what do we do for controls in this scenario? Well, obviously, we're assuming we're working at height. And we're going to try to follow the hierarchy like we talked about earlier. And again, with regards to planning, we want to think about protecting not only the worker who's working at height and at risk of falling, but also all those other people that are in the area. So I usually start with the other unprotected people. That's just been my preference over the years when planning stuff. So step 1 to me, before we would ever remove this guardrail or have this guy look into setting up his restraint system, is figuring out a way to get a barrier around the work area without any gaps with some signage that warns people that we're taking that guardrail out and that this area is now a fall protection area. Again, signage is really important on construction sites, especially because it's a changing environment. You might have people who are popping into the work site on a particular day. They haven't been there in weeks, and they didn't know that this type of work had begun. And you know, they weren't sure what to do when they got to, say, some flagging. Maybe they needed to access something in the unsafe area. So you want, again, some kind of soft barrier, or ideally set 6.5 feet back from that edge, or a hard barrier, certainly, if you don't have that much room. And again, you want your signage present. So the next step to me is looking at, okay, the guy who's actually going to be working in that area. So step one, he needs to be tied off somewhere sensible. Again, we're going to assume that this is a brand new building. We got structural steel, we got maybe concrete columns full of rebar. Seems like a reasonable place for him to tie off or use as his anchor. We want him to be able to get near the edge of the roof so that he can grab the tag line for whatever load is coming up. Again, let's just say we're using a crane, so he can bring it into the safe space. So he's got to be able to access that area, but we don't want him to have so much line that he could fall over the edge. So again, we're looking at how long that lanyard should be, or lifeline, and we're trying to ensure that it is fixed and not adjustable. And we also want to make sure that there's enough room in that laid out space for the materials to be placed without his lanyard or lifeline getting in the way. So I think we can kind of see how this is a reasonably decent setup overall. And again, I hope that kind of puts some perspective on some of the stuff we're talking about. Now, I do have a couple of other scenarios that I also want to just touch on, as long as we have some time. So here's another example. We've got a worker, or we've got a flat roof. So let's just say this is the top of a building. We've got a hatch that people can use, and that hatch just happens to be outside that 6.5 foot margin from the edge of the roof. So when someone gets out of that hatch, they're safe, they're protected. In this particular scenario, we've got two work areas that we need to do stuff in, Area A and Area B. Area B is within that 6.5 foot from the edge. So in theory, we could have workers go into that area without any type of protection on, restraint or arrest or otherwise, as long as they have some warning system in place to notify them when they're getting close to the edge. So we might, for example, put flagging or tape from the roof hatch right around the work area, just again to notify the worker that that area is safe, but they can't go outside that area. Now, work area A, on the other hand, is outside that 6.5 foot rule from the edge. It's, say, 4 feet from the edge. So we have to do something else there because we need to get to that area. So again, our options are, you know, something like a passive system, like a guardrail, which does mean that workers would have to install it. So that's something that needs to be factored in. That would be a risk. That system as well may be very expensive, and there can be issues around whether or not they're intending to keep that system in place or if this is just a temporary thing. So maybe it's not practical, is what I'm getting at. Again, our next option should be to look at restraint. Can he get to Area A from the hatch and use a restraint system that won't allow him to fall? And potentially he could. It really depends on, well, really a better view of the work area. It's possible that if we look at where that work area is relative to the hatch and we draw a line, he may very well need 10 feet of lifeline to get from roof hatch. Let's just say that's also the anchor point for this scenario to work area A. But it's possible if he walks directly from the roof hatch to the nearest edge, let's just say that's right here where I'm flicking my mouse around, that could be less than 10 feet. So this could be 10 feet, sure, and he needs to get over there. But if this is less than 10 feet, that worker has the potential, if they're tied off at the hatch, to fall if they go outside their work area, if they go over here, where again, the distance is less. And I do want to just highlight this because I've seen this a lot, especially on flat roofs. You find an appropriate anchor. Usually it's somewhere in the middle And then you want to be able to get to all aspects of the route, all the corners and everything. Again, if you're going to let your workers use a lifeline or a lanyard, it can only be so long as to allow them to get to where they need to work, but it can't be long enough that they could actually fall. So sometimes you've got to use a rest in these scenarios. Again, you need to think about the angles that workers may be working at and different little areas that they may need to access. So I think I'm going to leave it at that. I do have another scenario here, but I think I'm running out of time, so I'm going to leave this one alone. So again, just to highlight that issue, here we have, say 10 feet using this arrow, but like, in a different direction, it may be longer, I guess is really what I'm getting at. So to summarize, fall hazards are really common in many workplaces, especially when we talk about slips, trips, and falls, which we got into yesterday. There are many ways to protect your workers from falling. Again, if at all possible, we should try to use the hierarchy of controls to eliminate them from working at height at all, if we can. Or moving on to things like passive restraint methods like guardrails, again, if it's practical to use those because they don't require any training or really thought from the worker. They're just, you put them in place and you step away and it's done. Again, next is restraint, because if it's set up properly, again, the worker shouldn't fall. So you shouldn't need to deal with potential fall injuries or having to rescue someone who's suspended in their harness. But there are situations where restraint is just not practical. Again, if you have a large area and there's the potential for people to, say, in one particular section of your work area, go beyond what is safe for a restraint system. And in those systems, you've got to use a rest. And unfortunately, that's just, again, the flow through the hierarchy. So I do want to thank you all for joining me today, and I hope you did learn a little bit something more about restraint. I do find fall restraint is kind of a bit of a gap that maybe isn't covered as much in fall protection training and various other education means and venues that we go to. So I did kind of want to get into this into some detail. I do want to just again remind you about the future webinars, but before I turn it back over to the NLCSA, I do want to just check to see if I had any questions. So again, if you do have any questions, feel free to put them in now, and I'm just kind of give me a moment here just while I have a look. Okay, so I do have a couple of questions here, so just bear with me while I am trying to view them. Okay, just 1 second, people. There's got to be a way to make this bigger. I think what I'm going to do, if it's okay, is I might just ask one of the people from the NLCSA if they don't mind reading the questions out to me, because my screen is extremely tiny and I just am unable to get a full line of text to even show up here.
Hi, Jane. I can just ask you the questions there that I see some of our audience have there. So one question that we received here are, what about the emotional injuries associated with the fall?
Well, that's again a really good point. I have chatted with some people who have fallen at work and have been, say, for example, suspended in their harness. Again, by no means are they unhurt from that event. Really, fall arrest, if anything, brings you to a safer stop. But there can be some emotional distress, certainly, from falling. And I would imagine that some individuals probably carry that with them to future jobs. No doubt about it. I don't love heights. I mean, I have done a fair amount of work at height, but I think a lot of us have our limits to what we can put up with. And for some, it's that first experience of almost falling is really enough. I know for me personally, I hate swaying when I'm up at height, so I don't love getting in AWPs that are fully extended if it's windy out. I hate that. I get a bit almost motion sick, really, is the way I would describe it. But there's no doubt these injuries are stressful and could potentially um, be carried on long term in that person's career and even outside of their career.
And the only other question was just whether or not accessibility to a copy of the presentation.
Oh, sure. Well, I'm happy to give you guys a PDF version of this, and certainly I can give it to Tammy, I guess, and perhaps she can send it out. Would that work for you guys?
I think that would be good, and then we can pass it along to people. Yep.
Yes, not a problem at all.
Okay, Jane, I guess you're done, eh?
I guess so.
Just wanted to let everybody know that a copy of the presentation or a copy of the webinar is being recorded and it will be available on our YouTube channel a little later on today as well. So something that you wanted to use in your own workplaces with your workers, you'll certainly be able to access the entire webinar in a recorded format as well.
Perfect.
Okay, Jane, I'm going to take over for you. So thank you very much for that presentation. Definitely a lot of information within that brief period of time, and I could definitely tell that you could definitely provide us with a lot more information there if more time permitted.
It's a tricky topic to cram it all into one into 1 hour and a half session, certainly.
I know there's so much information, isn't there? But definitely a phenomenal job. So thank you very much, Jane. I'm sure everyone's going to appreciate just having this conversation here today. So what I have highlighted up here is just access to our website here. I just want to make sure everyone can see my my page here. But we have a number of resources here available on our website. If you click onto the NLCSA website and you click onto this Fall Prevention Awareness Week, this will take you to another website which will provide you with a lot of information. So, you know, given the purpose of this week and appreciating that falls are a leading cause of injury, particularly within the construction industry, the hope is that this website here will help create more awareness, education, and provide our members and, of course, employers with strategies and tools to help in preventing these sorts of injuries and unfortunately fatalities. So you'll find there a lot of documentation from sample procedures to forms, as well as toolbox talks on various topics about fall protection as well as prevention. And of course, if you're not up to actually giving the toolbox talk or you want to try something different, we also have some webinars and as well as the virtual toolbox talks, which were led by our team of safety advisors and professionals here. So we really encourage you to take advantage and use the resources that we have compiled here. So with that, once again, thank you very much, Jane, for your discussion. Definitely a lot of valuable information. And thank you everybody for taking some time out of your day to participate in this.